All right, it's day Squirtle. Whatever Squirtle is, it's that day. We love Squirtle. Today, I'm starting the third project. If we look at, did I not push? Yo, one sec, bruh. What? Oops. What the get push origin main. Wait, did that like fuck up? Hold on. Now I'm just getting distracted. It did. It's fucking annoying. Man, I'm so bad at Git. All right. Yeah, so we got these two projects done. We're doing 50 projects, 50 smaller projects. They're going to get progressively more difficult. Kind of. This one's going to be pretty hard, I think. I'm really nervous for this one. That's why I'm actually procrastinating right now. I'm keeping it $1 million. We're going to be building a ray tracer, a simple ray tracer. Basically, we're going to create some 3D shapes. You see this light right here? We're going to do that. We're going to do that right there. But with programming. How do you do that? I don't know. I forgot I had something to say, but yeah, this is we got these two done. It's pretty cool, pretty neat. So yeah, we're on the third thing. All right, let's get started. All right. And this project is going to be in wonderful C++. And dude, I'm not gonna lie, I'm gonna need some AI assistance for this project because I've coded in C++ one time. I'm like pretty familiar with like the super basics, but the problem is I just have no idea how to. Whoops, what did I just do? Like, cause this project is gonna take some matrix manipulation, some linear algebra, and my dumbass doesn't know how to do that. So I told ChatGPT to write me a little bit of an outline. Day one, basic structure and vector math. Whoops. Vector 3D, this will handle 3D points and vectors for your ray tracer. Implement basic operations. Okay. Vector 3D class. Do you make all this in the include in the header file? There's gonna be a lot of friction with this project. Man. Do I? Does he know it's C++? Yeah, he does. Okay. Scalar multiplication. What is that? What is an operator? Vector operations declaration. Okay, he Loki just gave it all to me. What is this operator? Is this a keyword? What the sigma? Okay, hold on. And so all my vectors are going to be vector. Oh boy. Dude, guys, I'm not going to lie. I got a C in linear algebra. A C, all right? I don't understand anything in that class. What am I looking at? What am I looking at? All right.
In this video, we're going to talk about how to add vectors.
Are we? Vectors by means of components. Don't you just add all like, you just add like the x, the y, like if you have, like you have a vector, why is it pink? Is it pink though? Am I right, guys? Is it pink though? If you have, like if you're adding, like this is v1, and this is v2. It's like 2, 3, 4. I'm pretty sure the resulting vector is you just add like 3, 3, 6. I'm pretty sure this is it, but I'm not sure. Why is this video 15 minutes? Okay, okay, that makes sense. Nah, he's pulling up the tangent though. Why is he doing that? Yeah, I know about this. That makes sense. Do you not just add them together? What the sigma? Okay. Did he not just do that? Why is this y plus v dot y and z plus v dot z? How do you use them? Addition. v3 equals v1 plus v2. And that just works? I understand the scalar multiplication. I get that part. But I'd rather use a library to do this. Or maybe I should do it all from scratch. I don't know. I don't understand. Like, it takes in just this, and then it just knows, like, this. Where does this x come from? Okay, vector 3d dot hpp. Sure. Sure. Oh, I've never used an HPP. I usually use just .h. I don't know if it matters. Okay, I have to remember all this stuff. What is it? NDiff. Okay. I'm going to be referencing this a lot, though, because I don't remember any of the public. Why are they all public? I guess it's just how he wants to do it. I really hope a lot of this project isn't just going to be me looking at ChatGPT's help, but I don't really know how else to do it, because like, you know what I mean? Like, I don't really know the syntax, and I don't really know anything about vectors, so it's like, bro. All right. Okay, I know that right there. That's easy. And then vector 3D double X double Y. Y is the syntax. Oh, it is. These are slightly different. Are they? No. My theme sucks. Why are they not different colors? Okay, now this is what I don't really understand. Operator plus. So I'm changing the plus. Const vector 3D, a reference of it. That's not a reference, is it? It is. And then V for vector. Then why do I need this const shit at the end? What does that do? Const at the end of a... In C++, const keyword at the end signifies that the function is a constant member function. This means that the function will not modify any non-static data members. Got it. Okay. That's valid. That's valid. That's valid. Okay. Minus. Yeah. Reference V const vector 3D operator multiplied const double scalar. Man, I just like remember this stuff like so vaguely from linear algebra. I don't get that though. Cross normalize. Okay. Oh, what is this? I thought you just multiply them. Okay, screw this, bro. Formula. Oh god, what the? Is it really that hard?
Please just make sure you guys have the dot product. You will need to know it. So if you have u dot v, that's basically going to say that's going to be u1 times v1 plus u2 times v2. Okay?
Yeah, so that's just not what this says. Is this a different dot product? First vector, second vector, dimension of vector space, component, component. No, is this summation? Yeah, this makes sense to me. Then what is that? This is the demon's formula. Oh, is this how to do it without the summation, maybe? Or something? That's probably it. Hopefully. I don't know. We just do that, though. So, I don't know. But I don't understand dot. Because, look, this is what he has for his implementation. Oops. Wait, does it not work? It does. Okay. This is what he has. Expected brace. Shut. Okay. Oh, now I'm confused. Why is this? Oh, that's why. That's what he has. Double vector. And I don't understand, like, okay, it takes in a vector v, right? And then where does this x come from? Where does this y come from? And where does the z come from? I'm guessing it comes from another vector. I think it comes from, like, when you do the dot product, you have to take two vectors. But I just don't get how, like, these. Sorry, I'm a little bit. I'm not even tired, dude. I just drank one of these right here. So I'm not tired, but I'm just yawning. But I don't understand, like, how would I use it? Okay, how? I'm guessing they're coming from where are they coming from though? Oh, I get it. I get it. Because you're going to do v1 dot, and then you're just able to access xyz, and that's why it's confusing. Yeah, because yeah, that's why he. But you didn't work with the pointer. You. Oh, wait, did you? No, you didn't use a pointer. This is just a regular. No, this doesn't clarify things at all. That's an important concept in C++. Let me explain. Let me tell you why you're stupid as fuck. Let me tell you why you're stupid. Let me tell you why you should quit. Let me tell you why you're an idiot. Regular object, not a pointer. Internally, C++ passes v1 to the dot product as a pointer. Dot function. It's a method. Okay, now I get it now. I understand how to code. Okay, no, I have one more question. Am I just really bad at C++? Yeah, why not use a pointer instead? Okay. So when you pass a... This is why AI is great. You know, simple like questions like this that like hopefully I'll get past. AI makes it so much easier to really understand what's going on. Wait, no, I thought... No, this makes sense. This makes sense. All right, and oh, it's double. Right, because it adds them all together. I forgot about that. And then what the sigma? All right, I'm gonna figure that out later, I guess. Yeah. Dot product vector 3D. Oh. And what is normalize? The process of transforming a vector into a unit vector by dividing it by its magnitude. Why is it over 5? One, two. Oh, because that's how long the vector is. Okay, that makes sense. Oh, and that's how you get the length. You have to do the Pythagorean theorem on the lengths, and then you get deadly with it. Got it. That makes sense. That makes sense. And I don't need it. Okay, he's saying, well, I'm looking at it. You don't need this because you're just going to use... Don't I need the variables? Where are the variables at? Double X y, z. And it's const again because you're not changing x, y, or z. That's cool. I'm a bird. I'm a bird, bro. I love to fly and stuff. That's kind of like one of my favorite activities. Yeah. If you ever see me in real life, bro, like what am I talking about? I'm sorry. Vector 3d.cpp. All right, hashtag include. Will it find it? Vector. Oof. 3d.hpp. And it doesn't know where it is. Okay, that's not good. Okay. Oh wait, did it find it? No, it didn't. Okay, I'm gonna cd03 build make. Why have we not found it yet? What seems to be the issue? Undeclared identifier. Okay, I'm gonna hold on. I need to include it here. Hashtag include vector 3d.hpp. It's not. That is not a good sign, everybody. Undefined reference. Yeah, I bet. Do I need to? Oh, wait, I need to do cmake dot dot. Cmake build dot. Man, something is wrong with this cmake file. God dang it, dude. Oh, do I need to add the executable? Oh, but look, I got further than last time. Undefined reference to vector 3D, double, double, double. Okay. Why is this not working? It should be working. Hold on. Why is it not working? Why is it not working? Vector 3D HPP file not found. And why is that? Okay, I'm gonna ask him, bro. I'm so bad at the CMake stuff, dude. I don't get it. Oh, I know the problem. I think. Wait. Is it supposed to be like this? / include. Shoot. Oopsie daisy, guys. But he's saying I can just do. Can I do include star? Can I? But that's weird though. Does this work now? Oh, I need to. Oh, that's just a wrong thing. Vector 3D. Double X. Double Y. Double Z. Dude, this. Why does my like theme or whatever? Like, why are these all the same color? Is something wrong with my like linter or whatever? Or like my LSP? Cause like I feel like that's just not good. Oh, I need to do this. Okay, this. Okay, but okay, I keep doing this on my second. It's just easier for me on the second monitor, but Lol. Lol. Okay, let's try that. Okay, now I think if I restart Vim, it should work. Also. Have we lost our minds? Maybe. But look, if I open this up in VS Code, look. This is the problem I've been having like recently. This is the one thing I can't get over with Vim. I swear this always happens. Look. It doesn't give me the error in here. Look, see? It's not here. But it's right here. Restart. Why does Vim not recognize? Is it LSP restart or something like that? LSP. Bro, like, come on. See, like this works, but it's giving me unknown type. How to refresh NeoVim. But why? But why though? I'm asking. Dude, like... I've had this problem before. This is not the first time I've had this problem. The problem is you just ask him, he like low-key gives you a solution, then you just forget. How can I restart this stupid language server? This right here. Oh my god, it's right here. It's right here. It's right here. It's right there. I know it. I know that. I know it. Oh my god. What the No, watch. I'm not even joking. It's just gonna fix it. CMake. Wait, CD. CMake. Dot. Okay, if I restart right now, I think that fixes it. Yep. Yes, sir. Okay, I'm just gonna put this in a folder in my computer. Or like, I'm gonna save that. Fix header files, CPP. Okay, we're back. We are back. We are so back. All right, we're back. We're so back. We're so back. Okay. Now I need to implement all these things. Vector 3D. See, why do I need to do now? I don't really understand why I need to do. Oh, because it returns a vector. And then now it's the object vector of. Now we have to do an operator plus here. And then we take the const of something. Vector. We take another vector, 3D. Take the reference of that. And we call it V. And then we do something special to it. Oh man, that's interesting. And we return a vector 3D where we do, can I do this? X plus V dot X. This Y plus V dot Y. And then this Z or V Z plus V dot Z. And it's not star. It's a plus sign. And this is wrong. Out of line definition does not match any declaration. Oh, I think, is it because I need the const? Is that why? Hold on. HPP. Okay. I think it's because I need this const here on the end of it. Const. Okay. Vector 3D. Vector 3D. Operator minus. Const vector 3D V return vector 3D. Does it need to be absolute value? It doesn't, right? Yeah, it's not. Okay. Let's test it out. And why can't I do that? Invalid operands to binary expression. Oh, because I can't just have a vector like that. Really? You can't? That kind of sucks. Make -4. That makes sense. Okay. How do you multiply them together? Is it what I think it is? Oh, const double scalar. It's not a V though. It's a scalar. Hold on. Double scalar. Is that right? Const. Oh, you gotta make it a const here. Okay. I'll make a little note here, or I'll make a note here. No, I won't. Hold on. I spell multiplication. Looks right to me. Huh. What's next? The dot product. Okay, I get that. Vector 3D. Return a vector. Do we return a vector? We return a double. Dot product, right? Dot product. Yeah. Oh, no viable conversion. Okay. The cross product. Dude, I'm looking at this cross product. I just don't get it at all. What is the cross product? Can we like learn about this real quick? Cross product.
Professor Dave here. Let's find cross products.
See what kind of comments we got going on. The most easy way to get a job is learning HTML, CSS, and Node.js. You can basically make everything with it. Cap? Right. Bro, there's like a lot of problems with that statement, but
Earlier in the series, we learned about
this guy thinks it's 2015, bro.
Including one way to multiply two vectors together, which we called the dot product. But the dot product is just a scalar. There is another way to multiply two vectors to get another vector, and this new vector is called the cross product, which is denoted by the multiplication sign. Now that we know a little bit about matrices and their operations, we are ready to understand how to find the cross product of two vectors. So let's learn how to do that now. Let's take two vectors, A and B. A has components 1, 3, 4, which can also be expressed as I plus 3j plus 4k. And B has components 2, 7, negative 5, which can be expressed as 2i plus 7j minus 5k. The way we find this cross product, or A cross B, is by finding the determinant of the following 3 by 3 matrix.
The determinants. Oh, I don't really remember how to do that though.
With I, j, and k across the top row, the components from vector A in the second row, and the components from vector B in the third row. We know how to get the determinant of a 3 by 3 matrix, so this is no problem. We just get I times the determinant of this 2 by 2 matrix minus j times the determinant of this one plus k times the determinant of this one. Now we can find each of these determinants. First we have negative 15 minus 28, then negative 5 minus 8, and then 7 minus 6. Simplifying and combining with the unit vectors, we are left with negative 43i plus 13j.
Oh, that's
plus
it?
k. So we can see how using determinants, we have found the cross product of these two vectors, which is another different vector.
Oh wait, that's it? Okay. I'll leave this up on my second monitor. He gave me the answer, but I really don't want to. I don't really just want to copy him, you know. Wait, why is it form? Yeah, why does it do that? Why is it so like? Okay. Do you subtract 28? Okay, so it's holy shit. Okay. Sorry, my brain is just not working. Okay, this J times v dot k. All right. And this is minus, no, plus or minus this k times, what is it, v dot j? Yes. Why is it minus and then plus? Who came up with that? Wait, hold on.
We must understand, and then 7 minus j times the determinant of this one, plus k times the determinant.
It's just how it works. Like there's a minus here, and then there's a plus here, and then that's just how God intended. Okay.
Determinant of this one. Now simplifying.
So we're gonna do a minus here, and then it's gonna be this I times v dot k. What? -5, -5. Yeah, that's right. Minus this I times wait, -5. And then, oh, v dot I, whoops. V dot I times 4, which is this k. And then plus seven. So this dot I, or this at spot I, one seven v dot k minus this j times what? Hold on. 1 3 2 v dot I. No member named K? Oh, shoot. Okay. Okay, so this whole thing is negative. That looks really confusing. Okay, let's try it out. 1 3 4
and k.
R2, R7, -5. So this number should be -43. It's just not about to be -43, but ray tracer. Oh! Okay, this number is supposed to be 13. And this number is supposed to be 1. Look, you got the first one wrong. God dang it. God dang it. Can I like do this side by side? Because this is beyond confusing, dude. Okay, it's 1 times, so it's k. That's right. Minus this dot k, it's k, or z, and then x. That's right. Okay, so that's one wrong with that one. And that's right, v dot z. And that's wrong. It's y. And then that's right. And then this should be I or X. Okay. Okay. Oh. Hold up. Wait a minute. Okay. Jesus. Wow. That was really tough. What is this black square? Is it always? Okay. Oh man, that was a toughie. Now we just have to do this normalized one. Man, that was a toughie, dude. That was a toughie. What is the return? Vector. Okay. Is it? Const. Okay. I'm a bird. Okay, how do you square things in C++? Pow. But do I have to import math or whatever? I don't want to do that. C math. Isn't that already? I already have it. Nice. This x2 plus pow this y2 plus pow this z2 divided by 3. And then it's return. I guess I'll do it here. Okay, and that should just work. Okay, I think we got all the vector bumblications figured out. Um, can we just get an example? Is that Sam Altman? Sorry.
A vector is an object that has both magnitude, sometimes called size or length, and direction. Vectors are usually represented by drawing an arrow, magnitude, which on the xy axis. You also know that the length of your and the 25. Take this of your now normalized vector. Now you know that the start point of your unit vector is 0, 0. Its endpoint is 3 over 5, 4 over 5. Its magnitude is 1, and it moves up as you go from left to right along the x-axis.
Okay. I don't know, I think that's right. How would I know? Okay, it's right. Okay, now I need to create an array. Create array class. Okay, I can do that. Why do you need both of them? Okay. Context. Direction. Get a point along the way. Interesting. Point at parameter double t. Why is it a double? Well, shouldn't that also be a vector? Origin plus direction times t. Huh? I don't really understand what this is, like. Why is it only one value? Oh, but that's not an intersection. That's okay. What does the point at parameter method do? What is the point of it? The point parameter method is a crucial part of ray tracing as it calculates a specific point along a ray on a given parameter t. Here's a deeper dive into what this method does. Purpose. A ray can be mathematically described as starting from an origin point and extending indefinitely. That makes sense. The method point at parameter double t allows you to find a point along the ray at a distance t from the origin. Oh, and you just multiply by the direction. Oh, yeah, this makes sense. That's simple. Positive t moves forward along the direction. Yeah. Okay. Got it. That's interesting. Okay. Let's get back to coding. What the sig? All right. Okay. So I need to get this. But why are these private? Why are those private? Let me ask him. Oh. Out of line? What do you mean? Oh, it's like this. Okay. Out of line definition of array does not match any declaration in array. Oh, it's const. There you go. Okay. Okay. Now what do I need to do? Vector 3D get origin. How do you do that? Okay, we did those. That's exciting. Point at parameter. All right, that's what we just learned. It returns a vector, right? Why are these off skewed? Is it space? Oof. That's up. See, like, why does it do that? Is it a const? I didn't make it a const. Should I make it a const? It is a const. Okay, let me just double check, make sure that's right. Yep, that's right. Okay, maybe some styling. Okay. Got it. Now we got the array going. That's fun. Okay, we need a... Oh, whoops. Calculator point at z equals 0. Dude, we need a print. I'm going to add a print thing. Hmm. What? What seems to be the issue, officer? Undefined reference to array, vector 3D const. Vector 3D const. Why is it? I'm not really entirely sure what I'm doing wrong here. That's odd. So why is that wrong? Oh, what the Is this constructor wrong? I think the constructor is wrong. Possibly. This apparently has to be dot normalize. Apparently that's important. Vector 3D array get origin const. Return origin. Yo, what is the problem? What's the problem, gang? Yo, gang, what's the problem, gang? Undefined reference. What do you mean, undefined reference? Like, I don't understand why. I'm just gonna I'm copying, bro. I don't know what's wrong with it. The header guard should surround only the class definition. Okay, this guy's an idiot. All right, I'm just copying it all. I don't understand why I'm getting this error. Oh. Ah, man, it's just one of these problems, dude. Oh, God. Give me a break, dude. That's not annoying at all. Oh, yeah. Okay. Okay, I need to set up a sphere class now. Before I forget, dude. Okay. Hashtag if and def sphere underscore HPP. Hashtag defines. How do I check? I'm gonna try to do that myself. Oh man. Oh hell no! Oh hell no, dude. Why did it not pop up as a field? There. Okay. How to check if no, that makes sense. That makes sense. Each point will have a specific t-value representing how far along the direction vector the point lies. But the equation remains the same. This will be important later, so make sure you try this out on paper. There are 2 points that I haven't mentioned labeled as P1, P2. These are the points that we want to solve, as both of these represent a point of intersection. Speaking of these points, remember that we can solve for any point on an array. In order to get the locations of P0 and P1, all we need to do is find the correct T value for each of them. This is going to make our lives a lot easier, provided you remember a little bit of trig. Since now all we have to do is find one point instead of their exact coordinates. I don't understand how he's finding L. Like, okay, this assumes you have... Okay, so you have this ray, you have P1, you have P2, and then using... You have D. If you have P1, P2, and then this ray, you can get D. If you have D, you can get TC. Why do you even need... Oh, and TC is this whole line. And using TC, you can get L. See, like, this guy's, like, trying to explain to me about Pythagorean theorem, and then this guy just wrote, like, 14 different lines, dude. Like, I'm in Chicago's train station trying to figure this out right now. I'm on the blue line, you know what I'm saying? I'm not from Chicago. But, like, I kind of am, so. What am I saying? I don't know what I'm saying, dude. I'm just trying to figure out this math, and I just don't get it. we need to find D, which in this case is edge B. But how did you get these? T1 and T2. Wait. Okay, I gotta know. Okay, who is this person that wrote this? I'm Kyle Halliday. Hooking and hijacking DirectX 11 functions. All right, I'm not gonna lie, I don't really want to be exposing my thing like that, but all right. I found his GitHub. Damn, 200 stars? That's wild. C++. Huh. This guy seems to know what's going on. See, it's just like I do this thing where I just compare myself to these people, and this guy has been in the industry for a decade now. Led the development of augmented reality games and applications for iOS and Android using Unity 3D. Worked as a member of the iOS team to develop native mobile applications, Objective-C. That was 10 years ago he was doing that. It's kind of crazy, bro. Good for him, I guess. All right. Did I just close the thing I needed? Solve for TC. Oh. Okay. Wait, difference? Float can hold up to 7 digits, while double can hold up to 15. Okay, great. Okay, let's use this. Ray. Okay, that makes sense. Ray. What is this double T? Because we have the center and radius already. Point at parameter. I am struggling to grasp the concepts. Our origin, our direction. Man, I just don't really get. Okay, here's what I'm struggling, right? So this function, he has ray and sphere, right? And ChatGPT gave me this double T. I don't really understand what this double T is. The double T method is used to store the distance from the ray's origin to the intersection point along the ray's direction. Dude, what? What is this guy talking about? Double T parameter is the Oh, okay. How is it a float then? God, I've never been more confused in my life. What is L? Dude, I'm so confused. L equals C minus origin. The first thing we need to do is find the length of L. It's simple enough. Since we know the positions of both the center and right origin, L equals C minus origin. Man. So confusing. think that makes sense. Okay, I don't get it, dude. Like, I really don't get it. Honestly. Oh man. I just really first intersection point. I don't really get it.
In this video, I will go into detail on the ray sphere intersection. The first slide here depicts a line. So the 3D line is defined as all points P equal to the origin of the line plus the direction times the value t. So O is the origin of the line, and that is a 3D point with coordinates OX, OY, OZ. D is the direction of the line. This is a 3D vector, and the vector is equal to dx, dy, dz. And then t is a singular value which has any value between -infinity to +infinity. So using the O plus dt, we can obtain all points along that line. Here we see a 3D sphere. So the sphere is defined according to its center, CS, and CS is equal to cx, cy, cz. We also have the radius of the sphere, which is r. And then we're going to define the 3D sphere algebraically as all points P on the surface of the sphere, such that P minus the center, if we take the square of that, it will be equal to the radius squared. We now have the two equations for the sphere and the line, and what we're going to do is use those two equations to work out the point of intersection between the ray and the sphere. So we want to find the point P, as we can see here, which will be the intersection of the line with the surface of the sphere. So remember, all the points on the line are equal to P, where P equals O plus dt, and all points on the sphere are P, where P minus C squared, CS squared is equal to R squared. So the first step is to take the line equation, P equals O plus dt, and substitute that into the sphere equation.
What the fuck are you talking about, dude? I don't get it. All right, let's just see if it works, dude. Does that make sense? Does that make sense? Oh yeah, no, that does make sense. I think. If this is 1.5. So this should not intersect. How about this? See, I don't understand. If this is 1.2, like, how does it intersect at 4, 0? Oh, because it only goes that way until it hits it. Oh. Yo, if this was like 0.1, would this be a different number? Yes, I get it. Oh my. Okay, it is time for a break. Woo. All right, we're back. I'm not gonna lie, dude. I always expect my breaks to like not be that long, and then I take forever. But right now we're gonna make the camera 22 minutes. Just like a bug on me. Okay. Okay. Can you guys hear that? Yeah, you definitely can. Alright, it's over. Jesus, bro. Like, your bike's not fast, bro. You're not fast. Alright? Dude, I just don't get what I'm reading. Alright. With the use of AI, I can do anything. The problem is I just like I kind of want to learn the math, but like I'm okay with just knowing the gist. You know? And like kind of just getting a lot more familiar with C++ as I do that. See, and you just have like private, and you just have like 18 million variables going on. The position of a camera in 3D space. Okay, I can buy that. What is it? Direction where camera is looking? Yeah. How does it do that? Double FOV. It's pretty self-explanatory. Double aspect ratio. Ratio. Double near underscore plane. What is this? distance to the near clipping plane. Yeah, the clipping plane. And what does this do? Generate array for pixel coordinates. I don't really understand. Generate array for pixel coordinates. I think that makes sense. Okay. Direction equals dot normalize. Interesting. Okay. What was it? Direction? That's a vector? Yeah, of course it is. Dot normalize? Okay. Okay, now the confusing part. Okay, I don't understand this math. Like, what the fuck? Double FOV M underscore pi? Bro, what the? What is an. Okay, I don't understand what the near clipping plane is. I don't understand. Well, I guess I kind of don't understand all this FOV, but that doesn't really matter. Oh, that's a radian. Okay, got it. But then I like really don't get how this math, what this math is doing. Up, viewport height. Dude, what the sigma? What the sigma, guys? I don't want to expand. I just want to see some code. Okay, let's see what we got here. A simple camera. Oh, and it's in C++. Origin, direction. I got that. Sending rays into the scene. understand how this camera is being set up, bro. Assuming Y is up. Calculate the lower left corner of the viewport. Return array position underscore array direction dot normalize. Yeah, I just don't get it. I don't get it. I understand this. Like what we're basically doing. Like we have the image, right? Here, maybe it's better if I just like. Wait. This is not working the way I need it to. Okay, we have the image, right? This is like our scene. We basically have a camera. I think it's right here at the bottom. No, hold on. I can draw this better. Like this. Shoot. Like this. Like that. No. Yeah, okay, so this is our scene. I think this is our camera. And the camera like shoots like where the camera's gonna shoot out like shoot boom, 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 all over, like, I think depending on how many we want to do, how many pixels there are, right? And we're just doing like one of these lines. Like we're doing the math to get just one of the lines, and then we're gonna run it through a for loop, so we can get all the lines. But we're just doing the math to get one line, and I don't get it. Like I don't understand what the near plane is. Okay, how to get viewport height. Math. That's not what I meant. Okay. Lower left plus okay, got it. That makes sense. Got it. Height and width defines the size of this window. The rays we trace will pass through the viewport, projecting the scene onto a 2D plane, like projecting onto your... That makes sense. Okay, that makes sense. This makes perfect sense. How do you get it? Okay, but then you use this tan shit. Like, why did you use tan? I get this. If a dot product is 0, the vectors are perpendicular. If it's positive, they point more in the same direction. If it's negative, they point in opposite directions. Let's say we have a camera at some point in space and a viewport in front of it. The ray direction for each pixel on the screen is calculated from the camera's position to that pixel. Bro, what? Let's say we have a camera at some point in space and a viewport in front of it. The ray direction for each pixel on the screen is calculated. The ray direction for each pixel. I understand this. The position of the bottom left corner of the viewport in world space. Ranging from 0 to 1. What is the near plane? Oh man. Ah. I don't get it. Oh, it's the wrong YouTube, bro.
So hello, and
Hello! So, in this video, we're going to talk about cameras. So, in the real world, a camera is an object, like say, your eye, that takes rays of light coming into it, and then it turns them into a picture. Now, if you remember back to the first episode, I said that we did ray tracing sort of in reverse, in that, in ray tracing, the camera is not an object that receives and detects rays, but it sends them out into the world to sort of probe it and see what it's like. Now, this means that our camera is not an object that needs to actually intersect with rays. Instead, it's an object that produces rays. So we need some way of understanding how real cameras convert rays into images, and then we need to reverse this process. So in the real world, the principle of pinhole cameras is used, as far as I'm aware, totally exclusively. So eyes use this principle, as do cameras, both modern and early cameras. So the idea is we have some sort of detector, and then we have a screen with a tiny little hole in. So, and this is all in a box. So rays of light can only enter through this hole. Any light ray coming in goes through this little hole, which means on the detector we now have very specific points corresponding to directions of light. And this is how you get a clear image. You sort of, each point on the detector only sees one very specific point in the real world, which is along that ray. So we can reverse this. So one important thing to note before we continue is that this will actually generate the image upside down. So if we have a little stick man here, you see this lowest point at the bottom actually goes to the top of the detector, and this middle one goes to the middle of the man. So you get something looking like this. Now, we would, in digital cameras, flip this upside down. In cameras with photographic plate, you can just flip it around. So this isn't a problem at all, but we do need to be aware of it, or we'll have all of our images the wrong way round. So if we try to replicate this by sending things out, so we can take up some physical space, and we can pick points on this, on a plane, a little small rectangular surface we have here, and then give them the direction to go at that point, and just keep them going. And then we don't need to worry about this screen, because we're only detecting rays going to that point. So we don't actually need the physical parts of this detector. But there's a neater way to do this, because here we have to worry about flipping the image round. But if we extend this box over, and we imagine that we have another surface here. Now, this isn't a physical surface that rays can hit. It's just something we're going to imagine to help us generate cameras. We can keep these rays going. And in fact, all the rays will pass through this center point and hit this surface. But what's neat is that if we have the image detected on this surface instead, then it's the right way up. We don't need to worry about it being upside down. Now, this wouldn't work in reality, because you're not able to filter the light out first. But we don't need to do that, because we're producing the rays. So any others that might hit our detector, as far as we're concerned, don't exist. Because we can just choose not to create them. So actually we can get rid of this whole part of the diagram. And this now gives us a much neater way of representing the camera. So we have its center point here. And now even in pinhole cameras, this is where it looks like the image is being taken from, the pinhole, not the detector. So by actually making this the point we care about, it makes it much more intuitive to see how the scene is built up from our given camera. And now if we can describe this surface, which isn't a physical surface, I want to emphasize that point, it's imaginary, to be used for creating the rays. If we can also describe this surface, and how points on the image we want to produce correspond to points on this surface, then all we need to do is take the ray that goes from the origin to the relevant point on the surface, and that then is the ray for that part of the image. So when we want to do this, there are lots of things we need to consider. So describing the surface that we want the rays to go through, there are several things we need to consider. So if we have this surface, one way to generate points on the surface is we start with a center point. And from this point, if we have two vectors, a right vector and an up vector, we can now just add together multiples of these two vectors to get any point on this surface. Now we're going to assume that these are normal vectors, so there are several things we need to consider. So if we have this surface, one way to generate points on the surface is we start with a center point, and from this point, if we have two vectors, a right vector and an up vector, we can now just add together multiples of these two vectors to get any point on this surface. Now we're going to assume that these are normal vectors, so they each have length 1. Now this means we need to consider the height and the width of this surface, because these are going to be the maximum multiples of these two vectors that we can use. And notice we choose this center point as the origin. Effectively, this is the 0 point. And we do this because if we have the camera looking at the surface, we can have a forward vector, and this will then take us to that very center point. And so actually, the direction we want, the correct direction vector, can just be made by taking that forward vector and then adding on the correct multiples of our up and right vectors to move on to the right point of that surface. So just by using multiples of up and right and adding on forward, we have the direction we need, which is great. But we need to think about what multiples we use. So generally in computers, an image is represented by a big grid of pixels. And what's a little awkward here is that 0 is up here in the top left. It's not in the center. And ultimately, we're going to want pixels in a grid rather than vectors. So we need to be able to convert between these two formats. And also, this is in pixel width and pixel height. And our surface is not using those same measurements. Our surface is using some sort of spatial measurements in our world. And it's really awkward to convert between the two, because there are other factors rather than just the size of the image that matter here. So first of all, we may want to increase the pixel count, but use the same image plane to get just a higher resolution version of exactly the same thing. But changing the size of the image plane is the same as zooming in or zooming out. So they're not directly connected. So let's think about how we actually get the right size of the image plane. So there are two pieces of information we need for this. We need the field of view, or shortened to FOV, and we need the aspect ratio. So the aspect ratio we can calculate from the pixel width and pixel height. So it's just the width divided by the height. Sometimes it's written in other ways, or the other way around, but this version of the aspect ratio is going to make our equations the neatest. And now we also need to know the field of view. So again, there are several ways of describing what it might be that will give you different results, but in this video we're going to consider it if this is vertical, so this is Y up here, this is the field of view, this angle here. So bear in mind that the screen still goes below, but we only consider part of this field of view. And we're also going to measure the height in a slightly funny way. So this is 0, this is height, and this is negative height. So the actual height of the screen is 2 times h, which seems odd, but doing it this way will make the equations neater in the end, I promise. And so we will be given the field of view. The field of view is part of describing the camera. So a really small angle is similar to being really, really zoomed in, and a really big angle is similar to being zoomed way, way out. And as you get close to a right angle, you get this sort of fisheye effect that you might have seen before. Bear in mind that you can't increase the FOV beyond 90, and you can't make it negative either. And so now we have this field of view. We can actually go ahead and we can calculate the height of our image plane. So if we just take part of this image, and not the whole thing, we get ourselves a right-angled triangle. Now, it would be really helpful if we knew the length of either this side or this side. So let's just imagine that this side has a length of 1. Now, what this represents is our forward vector. So as long as we ensure that our forward vector is normalized, that is, that it has length 1, this model still works. So we have to be careful with that, but otherwise, it's fine. And now once we've done this, we can use a bit of trigonometry. So this gives us that the field of view is equal to the tangent of h divided by 1, which is just the tangent of h. And now, reversing this, we get h is the inverse tangent of the field of view. Wonderful, we've got the height of our surface.
Which is this? Oh, and near plane is, wait, pause, is near plane the forward vector, possibly? Oh, shit. Come on, bruh. No, I get that, but like if you use the near plane in that
here. But we also need the width. Now, we want it to match the dimensions of the pixel. That is, we want its width and height to have the same aspect ratio.
Oh my God.
Otherwise the image will look stretched, and we don't want to have to do that. And we set up here, the aspect ratio is the width divided by the height.
Shouldn't the height be the tangent of the FOV? Why do you divide it by 2 though? Is it because there's like, I don't know.
So the width is just the ratio times the height. So this is really good. We can now describe the width and the height of our sort of imaginary image plane that's floating 1 unit in front of the camera. And so now we have this surface, which I'll draw out a bit bigger here. So this is the point 0, 0. This is our up vector. This is our right vector, which we will worry about calculating later. For the moment, we can just assume they're part of the definition of the camera. But notice that I said, well, h is up here, and negative h is down here. So in a way, its height is twice that, and that means that our width is over here, and our negative width is over here. So actually, its width and height are twice what our h and w are. But this means that if we have, say, alpha u plus beta r to represent a point on the surface, alpha can vary from negative h to h, and beta can vary from negative w to w. And now we've got these ranges that alpha and beta can vary between. That's really helpful for converting between the pixel image and this floating screen in the middle of nowhere. If we're not too worried about converting straight back to pixels, we can already describe the rays. So as long as we're happy with a funny coordinate system that goes from -1 to 1, then we can describe any vector as our forward vector plus h times y times up plus w times x times right. Now, this is where x and y vary between -1 and 1, which is a slightly unusual coordinate system. But this is sort of taking hy and saying this is alpha, and taking wx and saying that's beta. And it still varies in the correct ranges, from alpha being -h to h and beta being -w to w.
Kind of lost me.
Because x and y vary from -1 to 1. But what's nice here is we don't need to care anymore about anything specific about this image. By choosing y and x, we can then get the right ray. And y
I get that.
and x always vary from -1 to 1. There's no longer anything specific about our screen in doing this conversion anymore. So now all we need to do is take a pixel grid that goes from 0 to some, let's call it pixel width and pixel height. And now we need to convert this into -1s to 1, a sort of x and y in here. So if we have our pixel x, this varies from 0 to pw. So first let's get it to vary from 0 to 2. Now the reason we do this is because the difference between the smallest and the biggest possible values in our target range is 2, from -1 to 1. So if we can get this variant from 0 to 2, then all we need to do is offset it a little. So to do that, we want to take twice px and divide it by pw. And this value here varies from 0 to 2. And now all we do is subtract 1 off this. This value varies from -1 to 1. So we can say our x equals this, and we will plug that x into the above formula, and we'll get the right horizontal value. We need to do the same thing with y, and it's exactly the same thing. Twice the pixel y, divide by the pixel h value, and subtract 1. And there we go. We've found a way to convert from a pixel grid onto this floating screen in the middle of nowhere, and then we can use this equation up here to get the direction of the ray. Bear in mind that we will need to normalize the result of this equation to make it length 1. And we already know the origin of the ray. It's the origin of the camera. So we have everything we need to generate rays. So now I'll talk about how we actually produce a camera in code. So we could give it all of the pieces of information we've talked about. We can give it a forward vector, a right vector, an up vector, an origin, an aspect ratio, a field of view. But I mean, that's a lot of information to give it, a lot of data points to pass in. And not only that, but a lot of these satisfy very specific constraints. The forward, right, and up vectors actually all have to be perpendicular to each other. And so we can't just take anything in. And so we'll use a method that takes less information in and is a bit easier to use, and will produce a valid camera for a much larger range of possible inputs. So we still need to take a field of view in, and this still has to be within the range 0 to 90. But then instead of taking forward, right, and up, we'll take a target and an up, or rather an up guide. We'll get onto why this is only a guide later. And so this gives the camera a point that it's looking at. And now, I think this is a bit easier to work with, because if you have a focus of your scene, then all you need to do is set the target point to be that focus, or a point around it. And then everything else is sorted. You don't need to worry about finding the correct directions and which the right is. We still need an up, but this is only a guide. So we can just set this to be the what we consider to be up, the opposite direction to gravity. And then we can sort of use this method we're about to go through to actually get the correct up vector. And we'll also need the ratio. If we're just going to pass in values from -1 to 1 into our camera, then we will need that ratio. And finally, we'll need the origin. We do still need the start point. But now we have all this.
But it's not even close to what I have. FOV, ratio, position, target.
This information, we can actually go and get our forward, right, and up vectors, which seem to be missing. So our forward vector is just going to be the target minus the origin. So this is the vector that goes from the origin to the target. But we do need to normalize this result. We need to make sure its length is 1. And now we can use the cross product to get all the other parts we need. So our right vector
that makes sense.
Is
I think. Right up. Oh, so he is doing that. Calculate the right and up vectors. Direction dot cross. 0, 1 normalize. Assuming y is up. Cross product.
It's going to be the forward vector crossed with our up guide. So it's important to make sure we get the cross product the right way round, or this would end up being a left vector instead, and the whole image would be mirrored. But now finally we can get the actual up vector from right cross forward. Now the good thing about doing it this way is that these vectors are now guaranteed to be at right angles to each other, though we do still need to normalize
Yeah, he
them.
did that right
So
here.
then we have a way to take an image and then take the pixels in that image and convert them into rays that we can fire into our scene. And then using information about the ray, we'll later be able to get the correct color for that pixel, and that's how we're going to build up an image. So in the next episode, we will go over the code for this, and we will use that to... Hello! So, in this video, we're going to go over the code for cameras. So, as always, all the code is available on GitHub, link in the description. So, the first thing we do is we have a general camera class. So in the last episode, I only talked about one type of camera, but you can actually create rays in all sorts of different ways. There's not this one way of
29 stars. He calls it a point, though. What does a point look like?
converting points on an image into rays. But for the moment, we're only going to actually implement one type of camera. I've just set it out like this, so if we ever decide in future that we want more, then we'll be able to do that without too much difficulty. So the one important thing a camera needs to do is to make a ray from some point on an image. So this vector 2, their coordinates from -1 to 1 in both the x and y, as we discussed in the last video. So then our specific camera, the perspective camera. So the things we need to store for this are, as we discussed previously, its origin, its forward vector, its up vector, its right vector, and then also the height and the width that we're allowing. So our constructor, as we said, doesn't take all of this information. Instead it takes an origin, a target, and an up guide, and it uses that to calculate its origin, forward, up, and right, and then it also takes in an FOV and an aspect ratio, which it then uses to calculate H and W. So if we go and look at how this is done, firstly the origin is just given the value that is passed into the function. And now the forward vector is just going from the origin to the target. So I discussed this subtraction. to get that vector in a previous video, and then we want to normalize it to give it the right length. These all need to have length 1. The right and up vectors are then also created using the formulas we discussed, though we don't need to normalize the up vector. The reason for this is that if we take the cross products of two vectors that both have length 1 and are at right angles to each other, the result also has length 1. So in fact, because right and forward have these properties, up will always have length 1, so we don't need to normalize it, and we can save a little bit of time there. Because we're only doing this once in each scene, it doesn't really matter, but it's not necessary. So we then need to set h and w. So these are, again, using the same formulas we discussed. We just take the tangent of the field of view for the height,
All right, hold up. I'm just gonna use this guy's magical code here. Fstream. Camera. It doesn't have the near plane. Does it? One, two, three, four. Yeah, he himself forgot the near plane, bro. Vector, vector. Bro, what? No, I'm not trying to update the... Dude, I think I got trolled with ChatGPT. I think this near plane thing is not a real thing you need. Damn, he's just wrong permanently. Look, 1, 2, 3. Okay, hold on. Okay, what's the first one? Position. Camera position. What's the next thing? Direction. Looking down at the z-axis. I think it's look at. Okay. FOV. Let me look at that YouTube video for the FOV.
And the width, we then just multiply that by the aspect ratio. So then the last thing in the camera is to actually make a ray. And this is very simple, using the simple forward plus the x coordinate times w times right, and the same thing for up. And then all we need to do is return the ray created from the origin of the camera and this direction. But we do need to normalize this, this vector, or we'll have incorrect distances later on. So now that we've set up a camera, we can actually start thinking about producing images. So I've also gone ahead, and then we'll get fill in the data for this for us. And then it needs to decide that I went through in the previous video. So all we're doing is DNR into the create, the pixel to be white.
What is perspective camera? You just called it perspective camera for no reason. So in theory, I should be able to run this and it should create an image. Would you believe that? You're telling me it created an image in that amount of time? Yeah, okay. Yeah.
Can I ask you a question?
Yeah, what's up?
Okay. So we were talking about earlier. The fuck? Basically, I can never pass like just size. I always have to pass ampersand and then the variable.
If you want to change it outside, yeah.
Outside of what?
Like if you want to, let's say there, what you could do is instead of this, you can just pass. You have it turned off?
Yeah.
Like let's say you return like 1,
Yeah.
and then you do size is equal to, and then the function. This will change size also. But without the ampersand, if you want to like have a secondary effect means it's not affected by the return. Do you know what I mean by that?
No, but
Okay, a function can do two things. It can return and it can have a secondary effect. Okay, which means it changes a variable that isn't the return statement. Like it changes like it like modifies.
Like if you have
it
a helper variable or something, it'll change.
Yeah. So the only way to do that helper variable is with the ampersand or to dereference it, passing a pointer. You cannot pass in without that. You are passing in a copy. It is a.
Okay, I think I understand. Because I was just getting an error. I was trying to like do just like without just size, and I was getting an error saying you can't do that.
Well, let me come one sec. I want to look. Give me a sec. Okay. The circle's not here, bro. Dang, why did it not intersect? Can I like print the array camera.get? Wait. God dang it. Print array or information. Array. Vector. Oh, there's your problem right there, bro. uh. It's the same fucking thing. He's saying you changed this. Did he change that? Or is he capping? I don't think I need that. Oh. Yeah, I think I'm gonna have to rework this entire camera thing. This camera thing's just not doing it for me. And this near plane is, I think this near plane is just deceptive and terrible. I don't know what it's doing. But why is it 0 permanently? I don't understand, like. It just doesn't change off this camera angle or camera position. Yeah, look at all these wonderful values that are being printed. Oh, they're all the same? No, they're not. That makes sense, actually. Dude, he's not gonna be able to help me with this, bro. I need like a... I need to actually do it properly, and I don't know how. All right, guys. I think I'm just gonna leak code. The rest of the day, it's been 4 hours and 30 minutes I've been working on this, and I'm lost, honestly. Probably watch some more videos a little bit tomorrow or something. I'll figure it out. But this has been tough. This has been tough. So. All right, we're back. We're back to some leetcode.com. I'm on the wrong thing. Dude, me when muscle memory. I have got a text message on my phone. Oh. Yeah, y'all want a secret technology? Like a productivity hack? See this? Bang. I just saved your dumbass 30 minutes. I don't know why 30 minutes, but anyway. All right, let's get an assessment going. Let's see what we got here. Sort colors. I've already solved this one. Bro, I've already solved this one, though. Can I use extra space? Can you follow up with the one pass algorithm using only constant extra space? Oh, one pass? I feel like I can. So here's my idea. Basically, if it's a 1, if it's a okay, 4 num in nums. If num is equal to 0, how to append at the first? How to append start of array Python. Insert 0 at index 0. Okay. Elif num is equal to 1. Res dot append wait, that doesn't work at all. Wait, let me just make sure. Have I checked? Let me just check if I've already solved it. Dude, the problem is I don't want to do the one. This is a medium? What? Okay, if it's a medium, I'm not wasting my time, bro. Hey, watch me complete this medium in the next 5 minutes. If num not in hashy, what am I gonna do? I don't know why I just did that face. Alright, 4 num in hashy. Res equals bang. Oh, I said I was gonna mark. Shoot. Can I get like a notepad? Alright. 4. Let's do that for now. 4 num and hashy. Four and okay, I'll do 4 entry. 4 entry. 4 num in range. Oh, but this is not in order. Okay. Why is this a set? Okay, I need to stop rushing, dude. What is it? I? Or is it 4? J. 0 to hashy at spot I. Oh, it's okay. Oops. Oh, I have to modify. Oh, I mean, I can just cheat, bro. Like, oh, that might not even work. Yeah. Ooh. Okay. For num in for I num in enumerate res nums at spot I is equal to res at spot I. Yeah, so I'm like low-key cheating. I'm not cheating, but like this is gonna work, right? Yeah, without problems. All right. Mark down the next one. All right. Remove kdig. Let's see what we got here. Given a string num representing a non-negative integer num and an integer k, return the smallest possible integer after removing k digits. Return the smallest? So you just need to remove the 432. Oh, this is a toughie, dude. Yeah, this is definitely a toughie. All right, well, if k is equal to the len of num, we'll just do some easy edge cases first because I'm procrastinating. Man, I don't know how to do this. The issue with the problem, you got this 432. This is what you remove, right? But like, why? Like, how did you know to skip over the 1? And how did you know you can't get this 9? Is this maybe like, is it like a sliding window? Like you start bang, bang, bang. And if you move the window 1 over, like if you move the window here and delete all these, that number is the smallest. And if you move the window, oh, but it can be any 3 digits. They're not consecutive. So this doesn't work. Because how do you know? Is it because these numbers are all greater or equal to this number? Like 4, 3, 2, it's all greater or equal to 2. That's why you just know not to delete the 1. And I don't know. There's a formula to this problem, and I just don't really know what it is. Because you somehow know not to remove this 9. Like, what comes to me is just like, oh, I'm just going to delete all the biggest numbers. And then that's going to work. It's not going to work. Like, you have K, like, 3. The first 3. And this number. If there are K numbers to the left that are all greater or equal to, you have to delete those. I'm going to write that down. K number of numbers greater or equal must delete. That's my first idea. That's my only idea. Because, like, you don't delete at this 2, because, look, 1... I mean, how big can K be? Fuck, dude. I think that's right, though, for some reason. I just really think that's right. I'm just really struggling to think about how I can implement it. Okay. I don't even know how to get the K biggest numbers. Like, I don't even know how to do that. But I think this approach is right. Man, I was really struggling to figure it out. I need to keep the min of a window. I think it is a window situation. But how do I keep the min of a window? Because getting the smallest number is n, is k. So it's n times k, or num times k. And then that's problematic. Maybe we should just try this out, like... Okay, let's just try this out, like the rudimentary approach, or like the thing. But I'm not gonna do any hash anything. I'm just gonna for I in range 0, 1, 2. I'm gonna do the k to the len of num. And then I'm gonna have this left pointer. Okay, and I'm gonna have a helper. Okay. Okay, let me just, man, I'm overcomplicating this so hard. I need to do substring. How to do substrings in Python. Start end. Is the end included? End. And this website sucks, dude.
because the index
Oh
of
my
end.
god. Oh my god. I don't care about you. I don't care. Zero, 1, 2, 3, 4, 5, 6. So the first one's included. It's inclusive, exclusive. Got it. Got it. What is it? K minus 1 then? K is 3. Then I want to include this 1. Wouldn't it be plus 1 then? So if it's 3. Wait, it's not K, it's... Wait, there's just so many problems with this code that I'm looking at right now. So L should be 2 here. 2. So it's 2L plus num. Yeah, there's just like a problem with this, and I don't know what it is, but this code sucks. Oh, I never... So 0, 1, 2, 3. I don't know how to do this, bro. I give up. How do you do it? Remove K digits, bro. How do you do this problem? 34! That means it's impossible. Greedy. It's greedy. Of course it's greedy. Huh? Stack equals for digit and num. While stack and K is greater than 0 and stack is greater than digit. If K is greater than 0, remove remaining K digits from the end of the stack. Wait, I'm confused what this does. I think this was a similar approach as to what I was doing, though. Why is K minus equals 1, though? While stack. Oh, he keeps track while he does it. Oh. Yeah, this was pretty similar to the approach that I had. Not if how do you do the ternary operator in C++ in Python? Return res if res else 0. Then he'll do res equals str int res. Oh, and I need to remove the trailing because the K. But I would need to remove this 12. Now it makes sense to remove the largest numbers. How does he do it so graciously? From the end of the stack. But why from the end? Oh, because the way this is set up, it's going to guarantee that property. Yo, is that genius? It's negative K, right? That's how you do it. Okay, I'm not gonna lie. I mean, dude, I was like kind of close, but using a stack, I don't know why I didn't think of using a stack. That's the thing, dude. When the world hates you. All right, how do you do that, bro? Remove leading zeros, bro. I like this problem. This is an interesting problem, though. Let me do it without the I'm gonna do it without looking this time, so I can like really interpret it. My score report is being generated. Let's see what kind of deadliness we cooked up. See, it typically takes less than a minute. Okay. Okay, I look, you just forgot it immediately. Let me just take a peek. 4-digit in while stack. This is the condition right here. This is the condition that's really important to understand. Stack, the biggest thing is greater than digit. Because that means that's like what that means. Stack -1 is greater than digit. Okay, wait, hold on. 4 and stack is greater than digit. Not well, that's what he did. But we have to do int. Stack.pop. And then he has the I mean, this is just a whole all around genius solution. Genius solution is a genius solution. Yeah, so hold on, print stack. Oh, I forgot to append stack.append D. This is a cute stack problem though. Can I just do like 0 equals false? Or if all right, now I'm kind of confused why this isn't working. Oh, it's a while loop. Okay, never mind. This problem's impossible. You can do it without, like, I don't even need to do this. Like, I can just do this. And that's allowed. Okay, that's a tricky problem. 34% acceptance rate is kind of insane, honestly. All right, let's do one more and I'm done for the day. Hmm. Do paragraph space or one of this. Do symbols count as words? Notice that the words in the paragraph are not case sensitive. Punctuation is ignored even if it's adjacent to words, and that hit isn't. All right. We're gonna map this word to occurrence. Word equals, okay, one of these. For C in paragraph. Dot lower. Can I? Symbols and numbers are ignored. I bet they are, bro. All right, let me just make sure that worked. Seems it did. Okay. I'm just gonna make a set. Is it like this? Oh, and they never have double quotes. They should have been double quotes then. Whoops. Print. Okay, I'm gonna get rid of the space right here. All right. If C hold up. Word equals bang bang. And then what do I want? I need to store a new array or the hashy. Right, okay. If C is equal to a space, if word in hashy at spot word plus equals 1, else, how many characters get 10,000? Okay. Hashy at spot word is equal to 1. Oh, we can do an extra one. If, okay, we need to hold up. Let me cook. No, let me cook. Band words. There's probably an insane optimization I can do right here that will make it like O of n, but give me a second. Elif C not in symbols word plus equals C. And Wait, I need to handle the case. I need to delete it. Probably kind of ugly way to do that, but okay, I need to print hashy. See what it prints. I'm forgetting the last letter. Is ball in here twice? Yeah, it is. If word not in banned words. And let's see if that works. Okay. 2. Nice. Output ball. Oh, I have to output the... It's guaranteed to be a unique answer, right? Answer is unique. Yeah, okay. For entry in hashy, if hashy its spot entry is equal to res, return entry. Should be key. I don't know why I'm saying the word entry. Let's change that to key. Okay. But we got ball. All right, so let's do, man, a dot, dude. Expected rows of band to have 1. Yo, band is length 0, and here it's a constraint that it's length 1. What? How am I even supposed to know? What? Oh, because I never do it here. Hold up. Do I have to submit to check that case? Expected B. Oh, so this is not one word? Man, there... Oh man, they just love doing that. Just give me the pass, bro. Come on, I did it. Thank you, Jesus. Okay, I really hope that was a medium. If that was a medium, I'll be proud of myself. If that was an easy, thumbs down for that. That's not an easy problem, but I did do it in 15 minutes, so it might be easy, man. You know what I'm saying? So, you are asked to cut off all the trees in a forest for a golf event. The forest is represented as an M by N matrix. 0 means the cell cannot be walked through. 1 represents any empty cell that can be walked. Oh, I need to do the notes. Pause, champ. 5, 22, 40. All right. There's my last Leetcode, so I don't have to worry about that no more. Okay. In one step, you can walk in any one of the 4 directions. This is just going to be a graph BFS, DFS problem. But I'll read it. If you are standing in the cell with a tree, you can choose whether to cut it off. You must cut off the trees in order from shortest to tallest. When you cut off a tree, the value at its cell becomes... Wait, what? Becomes 1? But this is 1 right here. Oh, 1 represents an empty cell that can be walked through. Ah, okay. But what, you can't walk through 0, 0? What does 0 mean? 0 means the cell cannot be walked through. 1 represents an empty cell that can be walked through. Okay, so this is a BFS. This is a BFS, but how do we want to go about the BFS solution to this problem? I think one way is to find... Oh, but there are going to be multiple 1s inside. Well, you just start at 2, though. 1, 2, 3, 1, 2, 3, 4, 5... 1, 2, 3, 4, 5, 6. Right, so you start at this 2. You count it. 1, 2, 3, 4, 5. And then you traverse a final time. Or something like that. I mean, there's probably a better way to do that, but basically you start at this 2 because it's the smallest number, right? Because 1 is an empty cell. And then you try to traverse the whole thing, and when the BFS stops, you say, oh, I'm done. And then if there is any cell that is not a 1, then you return -1. And if all the 1s are -1, then you return the banger right here. All right. Now, let's get to it. I feel confident I will be able to solve this one. If I got this on the interview, we're in business. You feel me? You feel me, Blood and Cuz? Yep, Blood and Cuz, bro. I've been watching too many, like, one of them cop shows and stuff. All right. Ders equals -1, -1. If you're trying to do this problem with me and you're like seeing like what is this Ders thing, it's over for you. This problem is not solvable for you. I remember when I first was doing these graph problems and people were whipping out the Ders or the directions. Black magic. All right. So min val is 2 4 Okay. This is gonna get really messy really fast though. If num Nice. Okay. Now we're about to work on the lovely DFS solution. Or BFS. BFS. IJ. If forest at spot IJ is less than or equal to 1, return. Do not pass go. Return, buddy. Yeah. Now we're going to get demonstrous. All right. How do I do this? I'm pretty sure I make forest at spot I, spot J. Equal to 1. But this is wrong. Because If it's less than 1, then you return because you can't go there. Wait, do I even need that? Oh, that's problematic because you can walk over. You need a visit. Yeah, you need a visit. There's no way to do this without a visit. Good old friend visit. Don't ever try to reinvent the wheel. Make sure you do a visit set. If ij in visit, return. You already were there. Why do you want to go there again? I don't know. Okay. Visit.add ij. If forest at spot ij is greater than 1, we're gonna have a res equals 0. Non-local res. Okay. And now we're gonna have the for move endures. Okay, how do I center, like, can we? Okay, ni nj equals move at spot 0 plus I. Yeah, that's right. If 0 is less than or equal to ni is less than rows, and 0 is less than or equal to nj, less than calls, and something else. Forest at spot ni nj doesn't equal 0. BFS ni nj. I'm just trying to think, like, the only issue I'm having is that I'm just kind of confused. Like, this feels right to me, but I feel like I'm missing a condition. Oh, it's not in order. It's not in order. Oh, it's not in order. Oh my god, it's not in order. Can you only walk through one empty cell that can be walked through? It's not in order. Okay, my confidence just went down. Shoot, that's tough. Because the thing is, you can go from 2. Oh, and it's not even. No, I mean, it has to start from 2. I start from the smallest number. But like this can be, like let's say this was a 1 and this was a 3, 4, 5. You can walk through this 1 and then go here. Right? So then I think the thing I'm missing, I need a cur or tree size. Right here. Hold up. Okay, can I just do this like is greater than tree underscore size. Tree underscore size is equal to the max of tree underscore size and forest. I don't know, bro. I feel like that's it, but there's always a problem. Dude, I don't feel confident anymore. Oh, no. Oh, yeah. Five. Yeah, that's actually right. Turn res. Should do like a -1 right here. If I do a -1, does it go to 6? Yeah, it does. Okay. Because that guarantees we cut that the one I'm starting on instead of doing a +1. I don't like that. Okay, so that works for that. Man, I'm trying to think like. Okay. An initial size. One, 2, 3, 4, 5, 6. This needs to be equal to res. Hold up. Let me cook. No, let me cook right now. Let me cook. If this is equal to 3 or 2, it's equal to 2, then we're in a really good spot. We're in a really good spot. Okay. If num is greater than 1. Okay, if num Doesn't really matter what we add as long as it's unique. Return res if len of okay, let's see if this gives me 6. This is a little weird how this is returning me 4, 5, 6, 7. Wait. Oh wait, this is it steps? I'm returning the amount of steps? Have we lost our minds? Why am I doing that? In one step. So this is 1, 2. We start at the 1. Oh, fuck. So I just BFS at every single one? But there could just not be ones. Oh my god, dude, why am I returning the amount of steps I take? That is so stupid. I'm gonna actually do like a for I in range 0 to rows for j in range 0 to calls num equals forest at spot I. Visit equals set, empty set, and then BFS if num is greater than 0, visit equals set, BFS if num is greater and num is less than or equal to min val. And this tree size thing is just kind of... See, now I've just overcomplicated it because I have to kind of refactor what I'm doing. Okay, this step doesn't count. How do you make it? What, in here? Probably. Does that guarantee that I'm moving? No, because I need this tree size. Dude, I bet I'm not gonna solve it only because is less than or equal to return. But that's not true though. Dude, it's actually so bugging me that I'm BFSing through this perfectly. And I just like this stupid step algorithm is the problem. Because the problem is this could be like, let's say this could be one. It's minimum, right? Was there only one solution? No, there isn't, obviously. If this was one, you could start here. 1, 2, 3, 4, 5, 6, 7, 8. And that would be a problem. Or 1, 2, 3, 4, 5, 6, 7. Instead of 6 if there was a 1 here. So you have to somehow know to go to this. Oh, you just BFS and it's just smaller at that one. But you have to choose the larger one. You can never go to this one. Dude, unbelievable. I'm not going to be able to solve this problem right now. Unbelievable. Okay, I need to implement steps somehow now. Steps equals 0. Like, what the... No, there needs to be a steps right here. Steps. 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 And that means something. Or zero, it just starts at 0. Probably don't need that right there. No, because steps could be 0. Oh my god. This is a stupid problem. Why is it steps? I'm just going to print the steps. I'm just going to see what that gets me. Print steps. Isn't that cool? Steps plus equals 1. And res equals flow infinite. Sure, let's just, does it crash on me? We got 7 steps, 6 steps. Why did we get 7 steps? 14 minutes remaining. Shut the... Well, we would return 6 steps. But how would I even get... Okay, let's go to this one. But why can't I start at 2? Wait, why is the answer not 5? 1, 2, 3, 4, 5. This answer should be 5. Dude, what? Why would I start at 1? Okay, this problem is horribly worded. Just terribly worded. Just horrendously worded. Whoever wrote this problem should probably give up and do something else, possibly. Six. I got 5 here. Do I have to start? Oh my lord. Oh my lord, I start at the top left. Oh my god, I start at the top left. Dude, you have to start at the top left. Oh my god, you have to start at the top left. No. No, you have to start at the top left. have to start at the top left. But why is this one 6? And this one is 5. But no, they're both 6. Oh my god, you have to start at the top left. Dude. No. Oh my. But it's still steps though. Dude, I'm actually so demotivated. I'm done. I don't care. I'm done. Nah, that's insane, dude. Like, they gave me a heart? It's just a BFS solution. I would have figured that out if I... Dude, I'm not even joking. I would have figured this out. What the fuck? I would have never figured that out. What the... Yo, never mind, bro. I wasn't even close. On God, though. On God, I wasn't even close. All right, bro. I think I'm done with these assessments, dude. I just get this hard question that's impossible, and it's over. Dude, I wasn't even close.